Hi everyone, welcome back. This video covers the second part of my presentation for Java Basic. So before watching this video, please make sure to watch my video for the first part of Java Basics. In the second part of Java Basics, we will cover more Java operators, including compound assignment operators, increment and decrement operators, equality and relational operators. I have also added two more sections to my Java Basics presentation. One is numeric types conversions and case operator, and one is about named constants. Compound assignment operators, which are also known as augmented assignment operators, combine an arithmetic operator and the assignment operator. A compound assignment operator is indicated by an arithmetic operator followed by the equal sign. The ones highlighted here are compound assignment operators. These operators are used to abbreviate assignment statements that assign a variable to an arithmetic expression that has the same variables as an operand. In other words, the assignment statement of the form variable equal variable operator expression, where operator is an arithmetic operator, is equivalent to the assignment statement of the form below. For example, this assignment statement count equal count plus 2 is equivalent to the statement count plus equal 2. The plus equal is called the addition assignment operator. Similarly, the assignment total equal total minus discount is equivalent to the statement total minus equal discount. And the assignment height equal height divided by 2 is equivalent to the statement height divided equal 2. And the assignment statement m equal m multiplied with a1 plus a2, okay, in parentheses, is equivalent to m multiplication equal a1 plus a2. And in the last one, the assignment statement n equal n mod factorial, or n equal n percent factor is equivalent to n percent equal factor. There are also increment and decrement operators that are convenient to use when we want to execute something during a loop, which we will learn later. So the increment operator, denoted by the plus as 1 to its operand. Similarly, the decrement operator, which is denoted by 2 minus signs, subtracts 1 from its operand. Note that both of these operators take only one operand, which must be an integer variable. So you can write the increment operator and the decrement operator either after its operand or before its operand immediately. If you write these operators after its operand, which is an integer variable, for example, variable n, then it will return the value of the variable n. So that means that if you write, that means that the value of this expression is equal to the value of the variable n before it is increased or decreased. Okay, and then after that it increased the value of n by 1. So the previous one is, so if you put the increment and the decrement operator after its operand, those are called postfix increment and postfix decrement. Similarly, if you put the increment or decrement operator before its operand, then it is called prefix increment and prefix decrement. So in this case, it will first increase or decrease the variable n by 1, okay? And then it returns the current value of n. So that means that the value of this expression could be the value of n after being changed, that is, after being increased or after being decreased. Note that the postfix and the prefix versions of an increment or decrement operator have the same effect if they are used alone in a statement. For example, these statements n plus plus semicolon and plus plus n semicolon both increase the variable n by 1, and that's it. However, they can make difference if they are used in statements that do more than just increment or decrement. Let's look at these two statements, which declare int variables n and m, initialize n to 0, and then initialize m to 2 times an increment of n. The only difference between these two statements is that the first one uses the postfix increment, while the second one uses the prefix increment. In both cases, variable n is increased by 1 and gets the value 1 after the statement executes. However, these two statements set different values for m. In the first one, variable m is set to 0 because this postfix increment expression returns the value of n before being increased, which is 0. So the value of n is 2 times 0, which is also 0. In the second statement, this prefix increment expression returns the value of n after being increased, which is 1. So the value of n, the value of m is 2 times 1, which is 2. Here is a complete Java program that also shows the difference between prefix increment and postfix increment. In this program, we declare an integer variable named c and just initialize it to a a value of 5. And then we print out the value of c before increment. And then we print out the value of the expression c plus plus, which is a post increment. And then we print out the value of c after the increment. So here you see that the value of c before increment is 5, and the value of c plus plus, which is the post incrementing of c, is also 5. And the value of c after the post increment is 6. And then we set the value of c to be 5 again, and then we repeat those three printf statement, but replacing the post increment with the pre increment. And so the value of c before the pre increment is still 5, and the one after the pre-increment is 6, just like in the case of the post-increment. But the value of the pre-increment expression plus c is 6 instead of 5. So you can see that that's the difference between prefix increment and postfix increments. Recall that decision steps in an algorithm involve testing a condition. A condition is an expression that can have one of the two values, true or false. Those are called Boolean values. A condition can be a simple comparison, which can be formed by equality operators and relational operators. All of these operators are binary operators, which means they take two operands, and all of them associate left to right, right? Meaning the left operand will be evaluated or applied before the right operand. There are two equality operators, equal and exclamation point equal. The equal operator returns true if and only if its operands are equal to each other. The not equal operator returns the opposite value of the equal operator for the same operands. Both equality operators have the same level of precedence. There are four relational operators: larger than, less than, larger than or equal to, and less than or equal to, all of which have the same level of precedence, which is higher than that of the equality operators. Here is the summary of the uses of the equality and relational operators. Since these operators are binary operators, you just need to place them between the two operands. For example, you can write x equal y. So in this case, x and y are the two operands. And this expression means x is equal to y. Right? So it can have the value of true or false. So recall that in mathematics or algebra, when you compare if x is equal to y or not, you use only a single equal sign. But in Java and also in C and C++, you have to use two equal signs to denote the comparison, because a single equal size means assignment. So in that case, if you remove one equal size between x and y in this expression, then that would mean you assign y to x. So to express that you are comparing if x is equal to y or not, you have to use the equal size. Okay? And the not equal is denoted by the exclamation point followed immediately by the equal sign. All other relational operators are denoted similarly as in the algebraic operator. For the larger than or equal operator and the less than or equal operators, since you cannot write this notation in a text mode, so we have to write larger than followed by the equal sign, and less than followed by the equal sign. Let's look at a simple Java program named comparison.java that demonstrates the use of equality and relational operators. In this program, we will first read two integer numbers from the keyboard, storing them in variables number 1 and number 2. So here we also use the scanner to input the integer values from the keyboard using the scanner method nextInt. And this is the first part of the program. After reading two numbers into number 1 and number 2, we use the equality and relational operators to compare them in the second part of the program. So number 1 and number 2 are the two operands of this equality and relational operators. To make use of the results of these comparisons, we use the if statement. In Java, the if selection statement allows a program to make a decision based on a condition's value. The if statement starts with the keyword if, followed by the condition, which is in parentheses. And we also need to specify the statement that will execute if the condition value is true. We will discuss more about the if statement later in the next lecture. In this example, each if statement simply displays the comparison expression between number 1 and number 2 of that if that comparison is true. For example, in the first if statement, if number 1 is equal to number 2, then it will display the expression that number 1 equal number 2, where number 1 and number 2 are being are replaced by their current values. Here are some sample runs of the comparison program. In the first run, the user enters 777 for both number 1 and number 2. So three comparisons equal, less than or equal to, and greater than or equal to between these two numbers are true and are displayed. In the second run, the user enters 1000 for number 1 and 2000 for number 2. So there are also three comparisons that are true between the number 1 and number 2, including not equal to, less than, and less than or equal to. And in the third run, the user entered 2000 for number 1 and 1000 for number 2. And so here we also have three comparisons that are true between number 1 and number 2, including not equal to, larger than, and larger than or equal. We switch to the next section, which is about numeric type conversions and case operator. So to motivate this section, let's go over the arithmetic operation. Note that Java can evaluate only arithmetic operations in which the operand types are identical. For example, the division between a double variable and a short variable, as in these two statements, cannot be performed directly. So here, the variable n has been declared to be a short type, which is also a type for integer values. And total has been declared as a double variable. And so here we have the expression that takes total divided by n. So technically this one cannot be evaluated because the two operands have different type. However, that doesn't mean you cannot have such an operation in your code, because Java will apply implicit conversion rules for numerous times so that it can perform an operation between operands of different types. In particular, when evaluating an arithmetic operation between operands of different types, Java automatically converts the operand of the type with the smaller range to the type of the other operand. And recall that we have five primitive times for numeric value. And here is the list that is sorted in the increasing order of the range. So uh, the byte type has the smallest range, okay? And the short has the second smallest range, and then int, and then long, and then float, and then double. So if you have an arithmetic operation between the operands of different types, and if one of the operands has a type double, then the other operand will be converted to double as well. Okay, so in this case, in this example, the second operand, which is originally of type short, will be converted to double before the division is evaluated. Note that it only converts the value of the operand. It does not convert the variable in n into double. The variable n still has time short, but the value that is substituted here, which is 15, will be converted to the value 15 in type double. So that could be 15.0. Type conversion is also needed when you assign a value to a variable of different type. For example, suppose you want to calculate the ratio of students over instructors at a school, where the number of students is stored in variable n students, and the number of instructors is stored in a variable n instructors. Both n students and n instructors variable must be of an integer type because they only hold integer values. In this example, we declare variables n students and n instructors to be of type int and initialize them to value 21 and 5 respectively. Then the ratio of students over instructors is calculated as n students divided by n instructors. And we store the result in the variable ratio, which is of a type float, because we want to get a floating point value of the division. However, recall that the integer division use the integer quotient only. So the division of n students by n instructors use an int value of 4, which is the quotient of 21 divided by 5. So in this case, you don't get the value of 4.2 for the ratio. So to make this assignment statement work, a type conversion is needed because an int value cannot be assigned to a float variable. In this case, Java automatically converts the int value of 4 into the float value of 4.0 before assigning it to the float variable ratio. So after this assignment statement, ratio could have the value 4.0 instead of 4.2. Converting a numeric value to a value of type with a larger range is known as widening primitive conversion, which is done automatically by Java. Conversely, converting a value to the value of a type with a smaller range is known as narrowing primitive conversions and must be done explicitly by applying a case operator. Java allows you to make explicit conversion or type casting by using the case operator, which is formed by placing parentheses around any type's name. For example, you can make the conversion of the first operand of the division between n students and n instructors in the previous example by placing open parentheses float close parentheses before n students. This makes the first operand of the division to be of type float. Then the second operand is automatically converted to float by Java before the division is performed. As a result, it uses a float value which is 4.2 instead of 4. The portion open parenthesis float close parenthesis is a case operator. The case operator is a unary operator, meaning it takes only one operand. The case operator performs explicit conversion by converting the value of its operand into the value of the type specified inside the parentheses. But the value stored in the operand is unchanged. For example, when applying the case operator, open parenthesis, float, close parenthesis, to variable n students, the value of the variable n students is unchanged. The case operator associates from right to left and has the same precedence as the prefix increment and the prefix decrement, which is one level higher than that of multiplication, division, and the remainder operator. So in the example above, the case operator is applied to only n students instead of to the result of the division of n students by n instructors. Let's look at more examples of typecasting expressions. The first example applies the case operator of type int to the double value of 1.62, and the result is the int value of 1. Note that narrowing primitive conversion, such as from double to int, may cause loss of information and lead to inaccurate results. The second and the third examples apply the case operator of time double to an int value. Note that Java treats floating point constants like 1.62 or 4.0 as a type double, and it treats whole numbers constants such as 9 or 2 or minus 22 as of a time int. The operand of the case operator in the second example here is the result of the integer division of 9 by 2, which is 4. So the result of this time casting expression is 4.0. In the third example, the operand of the case operator is the integer value 9 only. So this division is between two double values of 9 over 2, which is 4.5 instead of 4. The last two examples are examples of converting between time int and time char. Recall that time char holds Unicode characters as values. In Java, a character constant is placed between single quotes, such as the character A in this example. And the fourth expression here, the case operator of time int is applied to character capital A, and the result is the Unicode of the character A, which is the same as its ASCII code, because character A is an ASCII character. In general, when a character value is converted to an int value, the result is the Unicode of the character. Conversely, when an int value is converted to a value of time char, the result is the corresponding Unicode character. For example, in the last expression here, the int value of 65 is converted to time char, and the result is the character capital A because its Unicode is 65. Here are additional examples that you can practice with. In these examples, I gave you three statements that declare and initialize values for variables A, B, average, and fraction. And it also uses case operator. So you're supposed to determine the value of each variable after each of these statements execute. Let's summarize the precedence and associativity of the operators we have learned. The only operator in this table that we have not learned is the conditional operator. This table lists the operators in the order of precedence from high to low. Those in the same row have the same precedence. The postfix increment and postfix decrement have the highest precedence and are applied first, followed by other unary operators including the prefix increment and decrement, the unary plus and minus, and the type case or the case operator. The unary minus is needed when you want to express negative numbers. The relational operators have the lower precedence than the binary addition and binary subtraction. The compound assignment operators have the lowest precedence, which is the same precedence as the assignment operator. All arithmetic operators, equality operator, and relational operator are associated left to right. All unary operators and the assignments and the conditional operator are associated right to left. The last topic we'll cover in this video is named constants. A named constant, which is also known as a final variable in Java, is an identifier that represents a permanent value. The value of a variable may change during the execution of a program, but the value stored in a named constant or simply constant never changes. When would we use named constants? Sometimes in your program, you could use the same value over and over again in many occurrences. In such a case, it's more convenient to give that value a name by declaring a named constant holding that value. For example, if your program makes several calculations that involve using the mathematical constant pi, and you don't want to type a long value of pi every time you need it, then you declare a named constant for the value of pi. The syntax to declare a named constant start with the keyword final and followed by the same syntax you would use to declare and initialize a variable. That is, you need to specify the data type of the constant and then the name of the constant and then set equal and then the value of the constant. By convention, you should capitalize all letters in a constant name and uses underscore to connect the words, such as in the name max value. Okay? Although you can use any valid identifier to name a constant value, but you should follow this naming convention for a good programming practice. And here are some examples of declaring a name constant in Java. So here we declare a constant named pi, and it holds the value of the mathematical pi. And here we also declare a constant named size and of time int, and it holds the value uh, of 3. This is the end of my presentation about Java basics. Thank you for watching, and I'll see you again in the next video, which is about control structures in Java.